Welcome in Corridor. Today we are going to learn a very important relation about the dispersive power. The dispersive power and the angular size or dispersion. Pay attention and concentrate with me. First of all, dispersive power. When light falls on a triangular prism, on a prism, any prism, this prism disperses the white light into 7 spectrum colors, as you know before that. So this variation, these 7 spectrum colors, due to the variation of the refractive index, and the variation of refractive index is due to the difference in the wavelength for each color, the difference of wavelength for each color. So from the relations, alpha equals A between brackets n minus 1. So alpha naught for red color equals A refractive angle of the prism n for red minus 1. So here A is constant. Why A is constant? Because it is the refractive index, refractive angle of the prism. A is the refractive angle of the prism, so it doesn't change. But here the angle of deviation is changed. Also the angle of position of minimum, the angle of minimum deviation is changed. Also the refractive index is changed according to the color, according to the light. Okay, so alpha naught for red equals A between brackets and red minus 1. That's for red. But here for the blue, alpha blue, here alpha blue equals A in the blue minus 1. Okay, so here alpha blue equals A in the blue minus 1, where NR is the refractive index for the red color or for the red light. And for N blue, yes, by subtraction, when we make subtraction, alpha blue minus alpha naught blue minus alpha naught red. Here alpha naught blue minus alpha naught red. So here when we make subtraction, AN blue minus 1 minus AN red minus 1. So here minus 1 with positive 1, yes, after subtraction. So the result will be, yes, A in the blue minus N red. A in the blue minus N red. So the left hand side, this left hand side represents the angular dispersion. The angular dispersion between, yes, between blue and red light. Between blue and red light. The angular dispersion. For yellow or middle between red and the blue, so alpha node for yellow equals A n yellow minus 1. A n yellow minus 1. That's for these points. After that, so alpha yellow equals A n yellow minus 1, or alpha yellow equals, as it is a middle between red and the blue, so alpha yellow equals alpha blue minus alpha red divided 2. So alpha naught is the average of alpha naught red and the alpha naught for blue. Then ny, the refractive index for the yellow, yes, is the average of n red and n blue. So omega alpha, the dispersive power, omega alpha is the dispersive power equals, be attention, alpha naught blue minus alpha naught red divided alpha naught for yellow. Alpha naught blue minus alpha naught for red divided alpha naught for yellow, or alpha naught only. So here AN, yes, here N blue minus N red divided NY minus 1. Why? Because A is cancelled with A. So AN blue minus AN red, A between brackets N blue minus N red divided A between brackets NY minus 1. So A cancelled with A. So omega alpha equals N blue minus N red divided N yellow minus 1, where omega alpha is the dispersive power and it is independent. It doesn't depend on the apex angle. It doesn't depend on the apex angle. Okay, so angular size or dispersion. Angular size or dispersion is the angle between the deviation angle of blue and red light. to the what? After emergence from the prism. After immersion from the, this is the definition of angular size. It is the difference. It is the angle of deviation. It is the angle of deviation between blue and red lights, between blue and red rays after emergence from the prism. The difference between them. It is called the angular dispersion. The angular dispersion or angular size. What's about the dispersive power? Dispersive power, as you see here, is a ratio between the angular size to the deviation angle of the yellow light. It is the ratio between the omega alpha, the dispersive power. The dispersive power, omega alpha, is a ratio between the angular size or the dispersion to the angle of the yellow lights, or to the angle of the yellow lights. Let's move to what are the factors affecting on the angular size of a prism. What are the factors affecting on the angular size of a prism? First of all, deviation angle, which is alpha blue, and deviation angle for red, alpha red. What are the factors affecting on the dispersive power? Of course, the dispersive power, omega alpha, depends on the angular size of a spectrum. Here, angular size or dispersion, and the mean deviation angle. And the mean deviation angle and the relation between them is inversely proportional. And now, with very important graphs. Here, the first graph, sine phi, and here sine theta. Sine phi on y-axis, sine theta on x-axis. Here, when we know the slope from this graph, sine phi divided sine theta equals 1 n2, means n2 over n1. So the slope here equals relative refractive index from the first medium to the second medium. That's for the first graph. What's about the second graph? The second graph here, n, the absolute refractive index, and here the reciprocal of the sine angle of the critical angle. The slope here, yes, here as you know, n equals 1 over sine phi c. Sine phi c equals 1 over n. So the product of the absolute refractive index and the sine angle of the critical angle will equal, yes, equals 1. So to calculate the slope of this graph, so n divided 1 over sine phi c equals n times sine phi c equals 1. So the slope of this graph equals 1. That's for the second graph. What's about the third graph? Here on the y-axis, sine alpha naught plus a over 2. On the x-axis, sine a over 2. It's very easy. So here, the slope equals sine alpha naught plus a over 2 divided sine over 2. It will be, yes, the refractive index of the prism. The absolute refractive index n. That's for the third graph. What's about these graphs? The fourth graph here, alpha, and here n minus 1. So here, as you know, alpha equals a n minus 1. Here alpha, yes, and here n minus 1 in this part of the equation. So alpha divided n minus 1, yes, the slope equals a. A is the refractive angle of the prism. Refractive angle of the prism or angle of the prism. That's for the fourth graph. What's about the fifth graph? On the y-axis here, I have alpha. On the x-axis here, n. And here intersects here at negative a. Negative a. So, as you know, alpha equals a n minus 1. Okay? When we open this bracket, so alpha equals a n minus a. A n minus a. Minus a here, this part. So the relation now between alpha equals a n. When we make a division, alpha divided n. So here the slope equals a. The slope of the prism equals a. Finally, the sixth graph, here we have n. The refractive index of the prism on the y-axis, and here alpha, the angle of deviation on the x-axis, and here is the straight line intersects on y-axis at 1. As you know, alpha equals a n minus 1. So by opening the bracket, so alpha equals a n minus a. So here n equals, from this relation, n equals, yes, alpha plus a divided a. N equals alpha, n equals, from this relation, alpha, n equals alpha plus a divided a. So when n equals alpha plus a divided a, n equals alpha plus a divided a. So n here equals alpha divided a plus 1. We make a division. A over a equals 1. So this 1 plus 1 here on the y-axis. So here n equals alpha over a. And here, to calculate the slope of this graph, so n divided alpha, so the slope equals 1 over a. The reciprocal of the refractive angle of the prism. At the end, I hope to understood our points for today: the dispersive power, the angular size or dispersion, the very important graphs as I illustrated for you. Thank you, and I hope to join us in the next chapter, and goodbye.